Hello, welcome to the shop. I'm back. It's been a while. No excuse really, just basic laziness and going off on different ADD tangents from normal stuff. But so one of the things I've been playing around with is Arduino, and had some thoughts I wanted to share on what it is for people who just have no clue. You've heard the name. It can probably be used in robotics and whatnot, but it's about as far as it goes. So you have no idea exactly what it is, what you can do with it, how you start, whether it'd be the right thing to give your kids to play around with. And that's really what got me down this line of thought, is just share my experience with giving these to my kids. I bought a couple of the real ones. This is a clone. I bought two of the real kits. Comes in a great big box for $100. This mounting board is laser cut, and you pop it out and you put it together, and you mount your little breadboard here and your little Arduino board here. Only modification I made to it was I put a couple of grommets in between the board and this, because it was kind of substandard the way the board fit against the wood, with the pins and whatnot in the way. So the grommets stand it off and make it work pretty well. So anyway, yeah, I bought these kits for the kids, and they were $100 a piece. This was a couple Christmases ago, so that was a pretty major expenditure around this household. I wanted to play around with them too. I didn't want to throw another $100 out, and so for Dad, I bought a knockoff board. These go for $15 or something, and they're made in China, and they get kind of sketchy with the fact that they, oops, looks like I hit my, there we go. They try to disguise the fact that this isn't a real one, but and some of them just go all out counterfeit. But this one, it says Arduino Uno. The one thing it doesn't go so far as to try to say it was made in Italy, which this is where the real ones are made. So that's one thing when we can tell them apart. As far as the quality of them, I haven't run across anything to distinguish them personally, but they're much more sophisticated people out there who can talk to that. I'm just saying that if you wanted to just get in this for absolute dirt, $15, but then the real kit comes with $20 worth of resistors and LEDs and all this kind of stuff, which I bought a little sample pack to go with my knockoff thing. I probably spent $50 to buy the equivalent bunch of stuff as you would get, with the real kit. That's including the board and everything. So, gave these to the kids, and to be honest, they really didn't pick up on them. I tried to, I'd make something on mine, show it to them, say, hey, well, just never really quite went anywhere. And the kids back then were 13 and 11. The son's 13, the daughter was 11. And I didn't push it. They have their other interests. That's fine. And I kind of set mine aside for a while too. And recently it's gotten to the point where, my son, he says he's started picking his up and he's interested, so he's 15 now. My daughter's like, Dad, I'm never going to mess with this thing. And so I've basically adopted hers, so I'll be playing with that some. But I wonder now whether there was a better way to go about it. And here's what I'm thinking. I'm thinking that for you to start off with the Arduino kit system, you're learning two things at once, two separate disciplines at once, in my mind at least, that could be broken down. You're learning the electronics that you're building over here on the breadboard, and you're learning the digital controls, which are programmed through your computer, which is what the Arduino board is basically. It's all around this chip, which I forget the designation for it. I think ATR, AVR, something like that. It's named after a couple of Scandinavian guys who invented it back in the 90s. And what it is this is a flash drive programmable logical chip, whereas everything that came before this, it was the type of memory that you had to burn. Programmable read-only, EEPROM, electronic programmable read-only memory, I think is what we used to call them back in the way back. So that's what started the whole Arduino revolution. Was first in the 90s they built this chip, and then these guys said, hey, let's make a basically a little kit board in which we can pin out from it, and we invented a software interface to simplify the programming of it, and so that's basically what Arduino is. It's that particular logic board with accompanying software that allows you to program it. And here's a bonus. This is kind of cool that I didn't realize until just recently, is that the language that you learn to program the board is based on C and C++. So it's not like you're learning some completely, off-the-wall, useless type of code that's specific to Arduino. If you learn how to program the Arduino, you're learning some C or C++. And so that's a bonus for me. I feel like that's good. That kind of increases the value of your time investment to get into this. So to get back on what I was talking about, whether I could have gone a different way that was perhaps better in terms of getting my kids interested in this stuff. And what I'm thinking is should have started them more with the electronics by itself. And then once they had played around and gotten interested in that, then you can start learning how to program it, which with the Arduino type technology. Which so if I were to go back to that route, I was watching this fellow in the UK called Fred in the Shed. Let's go ahead and unplug this. So I just have it in power now. The program is on the board right now, so you could actually plug a battery in here and it would do whatever you programmed it to do. So Fred in the Shed was talking about, look at these old kits. This is your Radio Shack Science Fair 130 in 1, and he was saying, yeah, I picked one up off of eBay for 8 quid, and I didn't have that kind of luck. I paid $30. You can buy them now, brand new, $30 from Amazon. And I don't know if they're like this. This one purported to be a vintage one, so I don't know if this is better or worse than what they're building now. I'm really actually impressed with what's on this thing. What I'm not impressed with is this cardboard construction. So if the more modern ones have plastic, I think that would be better. It's just, I can just see that if after a while of playing with it, you'd end up tearing it up. But you can certainly get $30 worth of education value. So what it's got is you've got everything you need to build a radio. Over here you've got an adjustable capacitor tuner. You've got a selection of resistors that you can connect in series and parallel and play around with all that. You got a bunch of capacitors. Oh, and the connections this particular type of breadboard uses are these little spring jobbers, which I'm sure you can imagine how they work, but just in case I'll demonstrate. There's, oops, and you've made a connection like that. So yeah, capacitors, momentary switch, fixed switch, diodes. It's all controlled. I mean, the power is supplied by 6 AA's, which you can choose to tap just 1.5, 4.5, or combinations. So you can see there's all sorts of experiments. You can, even if it didn't come with a project book, which it does, there's just all sorts of experiments that you could use this to conduct. Transistors, 3 transistors, an op amp, which I actually have never played with, so that'll be neat. This is a quad NAND gate, which I did play with back in the days of college. That's just a logic. If you've never messed around with this kind of stuff, it's not AND. NAND is not AND. So it's basically using voltage to duplicate ones and zeros in binary Boolean logic, binary logic. So yeah, so you're starting to get into that sort of logical circuit, and then all your basic stuff, resistors, capacitors, and whatnot. Got everything here to play with. And I think personally, if you've got a kid that you wanted to start sending down this path, I think you start with this or something like it. They have these things called snap circuits out now, which I've read mixed reviews. Everybody loves this. This gets great reviews. So I'm having fun with it. I'm hoping that my son will have fun with it, and maybe even my daughter. Maybe she'll decide, oh, that's actually kind of cool. I don't know. We'll see. But so that's my thoughts on getting into Arduinos and things for the very first time, whether you're 50 or 15 or 10. There you go. Talk to you later. Oh, I realized there was something I forgot to talk about in each case, whether you're talking about the Arduino or the Science Fair kit, the books. So this is one thing that'll set aside or set apart the official Arduino kit from just trying to cobble together your own components. You buy the real kit. You're getting the genuine board, and if you may think it's important also that you're supporting this is all open source, open development, and so you're supporting the ongoing Arduino thing. I'm not sure how much I buy into that, because I think these kids are all millionaires now and I'm not, so whatever. But you do get a book, and I've used it. It's both of these proceed through a series of projects, and some of the Arduino projects, I mean, it's a good progression of learning the board and the breadboard and the various little components. The projects, some of them are a little cheesy in the way they try to, I don't know, package them. So here's just using the board as a power supply, and so there's your +5 out, an LED. Then you get into learning to read resistors. So this one here, what did you do? Okay, the part that I think is really cheesy is they have these little cardboard cutouts that you can put over top of the board when you're done, and there's, I don't know, I can't see that really interesting anybody. But so here you've gone to where you're going to start controlling these LEDs. I didn't do this exact project. I switched to something different. I made it kind of like a little Knight Rider pattern. But the important thing is you've got sample code here, which will teach you the syntax, which is all programming is. I mean, if you can understand a flowchart, you can program. You just got to learn the syntax. So here you go. And as I said before, it's C or C+. So you're not wasting your time learning this. You're going to learn a valuable language that you can do quite a lot with. And yeah, so teaches you the syntax. This is how you write to the pin, digital write. This is how you declare a variable. That's actually just reading a variable, but here's an if-else routine. So all this is available, sort of something similar to this is available online, so, if that's the way you're comfortable reading things. I do often like to have a book. It's nice for me to set it beside the computer, so I'm doing my computer thing and looking at this. That's just me. Could be the difference between a 50-year-old and a 15-year-old. So, but I like the Arduino book that comes with the official kit, and I really like this book that comes with the science fair kit. You can see here some of the different things that you can end up. So you're going to learn all about the transistors and diodes and lots of things here. I mean, there's many hours worth of learning here, and I just have to say that just from flipping through or reading the first 10 pages, where it's taking you from, it's assuming zero knowledge and teaching you, particularly this section, where it talks about what all the components are. What is a resistor? What is a capacitor? What's a diode? What's a transistor? I have found this to be really well written. I wish I had read something like this many years ago. Just very down-to-earth explanation of what all the different components do. And so I'm looking forward to getting into building the circuits themselves. And I'm really looking forward to playing with transistors, because that's something I didn't do a lot of back in the day when I did dabble with this in college.